In this video, we are going to learn how to round a number in a measurement to keep a specific number of significant digits. This is the same thing you did before in rounding to keep to specific number of values or place in a number, like the 10th place, the 100th place, all those things that you did in elementary school. But in this case, we use the term significant digits to precisely determine in what location of a number that we need to keep it. First of all, to round at a selected, that means you choose a specific digit to look at. You look at the next digit to the right of that selected digit to determine the change of that selected digit. Notice how I use the word selected, okay? Because we choose a specific one. Now, if the next digit is 5 or greater than 5, then we increase the selected digit by 1. Before we move on, let's look at one example. In this case, round the numbers of the measurement below to have 3 significant digits. Okay? Here I have a measurement. Let's look at this one right here. So let's go back and count how many sig fig there are. In this case, it's a decimal number. So let's go back to the rules of significant digit. We have this decimal number right here. And for a decimal number, we're looking for the first non-zero, and all the digits after that non-zero will be significant. So in this case, this is the first non-zero, 1, and all the digits after that will be significant. In this case, 1, 2, 3, 4. So we have 1, 1, 2, 3, 4, 5. So we have 5 sig figs. But we want to keep this number to only have how many? To have 3 significant digits. So the third significant digit in this case is the first one, this is the second one, and this is our third one. So we are looking at specifically the 7. So this 7 is our selected digit. Now let's go back to the rounding. So again, we look at the next digit of our selected, in this case 7. If the next digit is 5 or greater than 5, we increase the selected digit by 1. So in this case, 7's right here is our selected, and we look at the next digit, which is 5. That 5 is greater than that 5. So since that is a 5, so we're going to increase the selected digit by 1. So therefore, this 7 will become an 8. So we have 0.00138. Okay? Let's look now. Before we move on, let's look at the other option. If the next digit is less than 5, in this case it's not, then the selected digit stays the same. In this case, it's 5 or greater than, so this becomes an 8. Now, one of the most difficult part is that what do we do with all the digits after the rounded or the selected digit? And here's the solution. First of all, any digit after the rounded number will become 0. Okay, so this 9 will become 0 as well. And what do we do with those 0? We are going to drop any 0 after the rounded or selected digit that does not add any values to the number. In this case, this 9 becomes 0. And if I remove this, if I put a 0 here, that 0 doesn't add any values to this whole entire number, so I can just drop it. So therefore, our number would be 0.00138. Let's try another number. We have a scientific notation number, and this is our coefficient that we're going to focus on, because we only focus on the coefficient number. In this case, we have 1.057, and we want to keep 3 significant digits. So this is a decimal, this is our first non-zero all the way to the end, so it gives us 4 sig fig. And the third one, or to keep 3 of them, we look at the third one. This is our first one right here, second one, and this is our third one right there, which is the 5. So again, we look at the next digit of the selected digit, which is 7, and that 7 is 5 or greater than 5, so that 5 right there will become a 6. And this 7 will become 0. So we have 1, 0, 6, 0. Did we keep this digit? No, because it doesn't add any values to this whole entire number. So our answer should be 1.06. There you go. Let's try another problem. Again, keep 3 significant digits. In this case, it's a decimal again. So this is our first non-zero. We're going to count all the way to the end. 1, 2, 3, 4, 5, 6. So we have 6 sig fig. And our third sig fig is 2 because we want to keep 3 significant digits, which is the 2 right there. So we look at the next digit after the 2, which is the next digit after the selected digit, which is a 7. And that 7 will make that 2 into a 3. And everything else after that selected will become 0, 0. So what we have is 3530.00. The question is this, do I keep this 0 over here? Well, this 20 doesn't add any value to the number, so we can ignore it. But this 0 right here, if I take that 0 out, it's no longer 3000 something, it will become 300 something. So I have to keep that 0. So what we have here is 3530. But do I keep the decimal? If I keep the decimal, how many sig fig am I going to have? 1, 2, 3, 4. Because going back to the rule, because for a decimal number, we start from the first non-zero and count all the digits after that non-zero. In this case, if we do that, it's going to be 4 sig fig. So that way, if we do that, if we keep the decimal, it will become 4 sig fig. So what we have to do is that we have to remove that 0. And now that 0 will become insignificant until a sig fig, but still adding the values to the entire number. So again, this is a very tricky question. So again, we don't keep the decimal because we want to keep this to be 3 sig fig. If we put the decimal there, it will become 4 sig fig. Now let's try another problem. I have 10.572, and in this case, round the numbers of the measurement below to have 2 significant digits. In this case, we are keeping 2 significant digits, so we're looking for the second sig fig. In this case, it's a decimal again, so count all of them, which is 5 sig fig, but the second one is the 0 right there. That digit 0 there. So we look at the next digit, which is 5, and that 5 will make a 0 into a 1. So we have 1.00, because any digit after the rounded or selected digit will become 0. Now the question is, do we keep the 0? Well, this 0 doesn't add any values to the number 11, so we just ignore it. So we just have 11. There you go. Now let's try another problem. We have 0.00133. Again, this is a decimal number. So this is our coefficient part, and this is our non-zero, so we're counting. In this case, there are 3 sig fig. And our second one is that first 3 right there. So we look at the next digit. That 3 is less than 5. So the selected digits stay the same. In this case, that 3 stay the same. So we have 0.00130. Now, do we keep this 0? Well, does this 0 add any values to the number? No, so we just ignore it. So what we have here is just 0.0013, and that's our answer. Let's try the last one. In this case, I have the same number as that one, which is giving us 6 significant figures. But in this case, we only want to keep 2 sig figs, so we're looking for the second one. This is the second one, that 5 right there. So we look at the next digit after the selected digit. In this case, we have 2. So that 2 was less than 5. So with less than 5, the selected digits stay the same. So in this case, we have 3, 5. And any digits after the rounded or selected digit will become 0. So that 2 will become 0, that 7 will become 0.00. The question is, do I keep this 20? No, because it doesn't add any values to this number, which is 3,500. If I keep it, it's still 3,500. If I remove it, it's still 3,500. Now the question is, do I keep that decimal right there? If I keep that decimal, we go back to our sig fig rule right there. If it's a decimal, then the first non-zero and all the digits after that first non-zero will be significant. In this case, we keep it, all of them will be significant, which gives us 4 sig fig. But we only want 2 sig fig. Let's remove that decimal. So we have 3500. That is significant because of non-zero. This is significant because of non-zero. But these 2 are not significant because it doesn't apply to any of the rules above. So therefore, we keep this 20, but we don't keep the decimal. And that is our answer.